In this lesson, we're going to take a look at working with monomial expressions. And so when monomials, which is a polynomial with one term, like a cubed or a to the fourth or negative 2x cubed, when they're multiplied, we combine together the like variables by adding the exponents. And I want to begin to explain why you do that, why that is the rule. So if we take a look at this product, a to the power of 3 times a to the power of 4. Now what a to the power of 3 means is that there's 3 of these a's multiplied. And a to the fourth means that there's 4 of these a's multiplied. A times a times a times a means a to the fourth. And so this really is a shorthand for writing this. And so notice that altogether, if we were to remove the brackets, then there's basically 1, 2, 3, 4, 5, 6, 7 of these a's multiplied. And so it would equal a times 7 of them multiplied. Now, instead of writing that out, there's a shorthand way for doing that. That's the same as a to the power of 7. And so notice that this is a 7 because there are 7 of them, and the 7 comes from the fact that there were 3 here and 4 here. So that's why you add the two exponents. So we could actually take this and write, before we get to our final answer, a to the power of 3 plus 4, which is a to the power of 7. So that's why when you're multiplying two terms with the same base, you add the exponents, because the exponent is really a count for how many of those a's or x's or whatever the variable is that are multiplied together. So first example, we're asked to multiply w to the power of 6 by w to the power of 2. And so we would add the exponents and we would get w to the power of 8. So when it's just 2 powers or more, if there were 3 or 4 powers, you would just add all of the exponents if the basis was the same for all of them. And so same idea. In B here, we're multiplying 5x by negative 2x cubed. Now, for the coefficient part, the 5 and the negative 2 get multiplied in front. So you just multiply 5 times negative 2 is negative 10. And then, now there's really, when you see the x here with no apparent power, it's automatically a 1. So x means there's one of them. So 1 plus 3 adds to 4. For C, just a little bit bigger here. Now, there is a coefficient of 1, well, there's a 1 there, so there's actually negative 1. So we would multiply the negative 1 by the 7. So that's going to be a negative 7 in the front. And so we would write negative 7. And then x squared times x to the fifth, we add 2 and 5 to get 7. And y to the fourth times y to the second, 4 and 2 would add to 6, so it would be y to the sixth. So the final answer here would be negative 7, x to the seventh, y to the sixth. Similar idea in D here. 8 times 4 would be 32 in front. And then G is the same as G to the first, so 1 and 2 would add to 3. H to the fifth times H to the third, 5 and 3 add to 8. So 32 G cubed H to the eighth. Second page, when monomials are divided, we combine together like variables by subtracting the exponents. And I'm going to explain why you do that here before we get into the example. So let's say we were dividing a to the power of 8 by a to the power of 5. So we could write it like this. Both those mean that we're dividing a to the 8th by a to the 5th. Now, this really means a to the 8th means that there's 8 of these a's. You can count them. 1, 2, 3, 4, 5, 6, 7, 8. And a to the 5th means there's 5 of them there that are in the denominator. Now, one way to simplify this is we could write it as, so what this is this first one is really, and it really doesn't matter which one, but I'm going to start at the beginning. So it's really this a over this a here, the second one over the second one here, the third one over the third one, fourth one over the fourth one, fifth one over the fifth one. So it's kind of like all of this is these 5 a over a's multiplied. Now, the top part, what's in the numerator, there's more a's there. Okay, so we actually stopped right here. So there's actually 3 more a's in the end multiplied. So that's what those 3 a's is. Now, a divided by a, no matter what a is, well, with one exception, and I'll get into that, is always going to be 1. something divided by itself is 1. So that's 1, that's 1, that's 1, that's 1, and that's 1. So we really could think of this as 1 times 1 times 1 times 1 times 1 times these 3 a's in the end. Now, it doesn't matter how many 1's you multiply, you're going to get 1. So this is really just 1. And so we really are just left with a times a times a, which would be a to the power of 3. Now, that 3 comes from subtracting the exponents, whether we write it in this form or this form. Dividing powers of the same base, you get a whole bunch of things basically to divide out to 1. And you're left with the number of a's or x's or w's or whatever it might be. The number you're left with really is the difference between the two exponents. So 8 minus 5 gives you the 3. So when we're dividing this, you could, as an intermediate step, write as a to the power of 8 minus 5. Notice the top exponent minus the bottom one, which of course is a to the power of 3. So that's a reasoning why you subtract the exponents, because you get a whole bunch of stuff to divide out, basically. So in this example, number 2, we're asked to divide. So w to the power of 10 divided by w to the power of 6. We would subtract the exponents, and 10 minus 6 is 4. Now this only works if the two bases are the same. If they're not, you cannot use this. The bases have to be the same. Otherwise, you wouldn't be dividing out the same things here. You like if I get a over an x, and that doesn't equal 1 unless you're told that they're the same thing, which wouldn't normally be the case. In B here, now if you don't see an exponent, it's automatically a 1. So 7 minus 1 would give you 6 for the exponent. So that would be k to the power of 6. Now for C, when the monomials get a little bigger, maybe there's a couple of different powers, coefficients in front, like the 12 and negative 3. Well, when we're dividing, you just divide the 12 by the negative 3. So that's going to give you a negative 4. And then you divide by subtracting the exponents. So for the x's, x to the 5th divided by x to the 4th, 5 minus 4 is 1. You don't have to write the 1 if the exponent's 1. And there's a 1 on the bottom here, so 6 minus this 1 would be 5. So negative 4x y to the 5th would be the simplified version of this. Now, I'm going to get into what a negative exponent, because it's related to this, means here. So well, actually a 0, and then we'll get into negative exponents. So to show you what a 0 exponent means, let's divide a to the 5th by a to the 5th. And we could do the division thing and subtract. Okay, so 5 minus 5 would be 0. So that's a to the power of 0. And, well, the question is, what does that equal? A to the power of 0, what is it equal to? Now, I'm going to evaluate this a different way, the same thing a different way. And of course, if it's the same thing, then it has to be equal to this. So instead of a to the 5th or the a to the 5th, we could write it as 5a's divided by 5a's. And then, so similar to up here, then this is a over a times a over a times a over a times a over a times a over a. And those are all 1's, each one of the a divided by a's. So 1 times 1 times 1 times 1 times 1, of course, equals 1. And so that means that a to the power of 0 has to equal 1. I evaluated the same thing, just two different ways, by subtracting exponents and then writing out the entire top expanded divided by the entire bottom expanded. I got all these 1 times 1, which equals 1. So that means that that equals 1. Now, the only exception to this, and I talked about this up here a moment ago, is that the base cannot be 0. Because if the base was 0, we would have 0 times 0 times 0, and it really doesn't matter on top. But the zeros on the bottom are what would give you a problem here, because that would mean if these were all zeros, you'd be dividing by 0, and you can't divide by 0. Also, 0 is the only number that dividing itself by the same number doesn't equal 1. Like 10 divided by 10 is 1. Negative 8 divided by negative 8 is 1, but 0 divided by 0 isn't 1. Okay, so that's why we put this restriction up here that the base can't be 0. Now negative exponents. So, and here's my restriction, a cannot equal 0 down here. W to the 3rd divided by w to the 5th. Well, we could subtract, and remember, it's always top minus the bottom. You don't just switch to 5 minus 3 because the 5 is bigger. So 3 minus 5 would be negative 2, so we get w to the negative 2 here. Now, there's a way to write that so the exponent is positive. And so what I'm going to do is I'm going to evaluate this a different way, just like I did over here, and write out the w cubed is w times w times w in the numerator, and w to the 5th, there's 5 of them in the denominator. And then do all this breaking up. So I have this W over this W here, this one over this one here, this one over this one here. Now, it's really like there's another 1 up here on top. So there's still a 1 in the numerator because W times W times W times 1 is the same as W times W times W. Okay, so there's still 1 in the numerator. And then I've used 3 of the W's in the denominator, so there's still 2 left. Well, each of these are all 1s, and then I would have 1 over W squared. So since this is all 1, 1 times 1 over W squared is still 1 over W squared. And so I've evaluated this 2 different ways, and so that means that these 2 things I got each time should be equal. So W to the negative 2 is equal to 1 over W squared. So this is how you rewrite this so it has a positive exponent. So the general rule is this: a to the power of negative n, being the negative exponent, is equal to 1 over a to the n. So it's kind of like you take the power and you bring it down into the denominator and the exponent changes sign. And of course, again, the restriction is that that base can't be 0. So a couple of examples here in F, because we have a couple of negative exponents. So we're dividing monomials. The coefficient parts we just divide. So negative 24 divided by 8 would be negative 3. Now, this is really the zero exponent rule here. X to the 5th divided by x to the 5th would be 1. Because 5 minus 5 is 0. We have x to the power of 0. So you don't bother write x to the power of 0 there. For the y's, y to the 10th divided by y to the 3rd, you subtract the exponents, so you get power of 7 on the y. Now for g here, if we divided 15 by 3, we get 5. And r to the 4th divided by r to the 10th, 4 minus 10 would be negative 6. So we want to write that so that the exponent's positive. And that's the normal accepted way instead of leaving the negative exponent. So I'm going to show you 2 ways to do this. Here, the long way kind of first, the sort of by the book way. So r to the power of negative 6 is 1 over r to the 6. So this is the same as 5 times, and we rewrite this as 1 over r to the 6 using this idea from down here. And so when I multiply 5 by 1, now this is the same as just 5 over 1. So 5 times 1 on the top and the 1 denominator underneath the 5 times r to the 6. Then I get 5 over r to the 6. And so that's how I can rewrite that with a positive exponent. Now that's not really that long, but that's kind of the long way to explain it. Another way to do this, though, is when we're originally dividing this, we could go, again, 15 divided by 3 is 5. That part's okay. But because the larger power is in the denominator, if we keep the power of r in the denominator in the bottom, then we're allowed to go 10 minus 4 because we're keeping in the bottom. Because we're keeping the bottom, then we're subtracting with that bottom exponent first. And so that gives you 6. And so if you do that, of course, you get exactly the same thing. So 2 different ways to evaluate that when you recognize that the larger power is in the denominator. Now, last we're going to talk about on the last page here is power of powers, the power of a power rule. So when we take powers of monomials, the exponents get multiplied. And again, I'm going to explain why that's the case, and then we'll take a look at a few examples from the bottom part of the page. So let's say we have a squared raised to the power of 4. Well, that power of 4 means that there's 4 of these a squareds multiplied. So if we go back to the very first rule where when you're multiplying powers of the same base, you add the exponents, then 2 and 2 and 2 and 2, all these 2's would add to 8. Of course, instead of just repeatedly adding them, we could think of it as there are 4 2's, because that's what there are. There's 4 2's here. 4 times 2 is 8. So that's why you actually, an example of why you multiply the exponents, because that 4 is how many a squareds there are. So 4 times 2 would be 8. So this is kind of the intermediate way to do it, to explain or show where you get the 8 from. Okay, so last example here, number 3, you're asked to simplify x cubed to the power of 5. So power of a power rule, we multiply exponents to the x to the 15. For b here, same idea no matter really how big that exponent is in the brackets. So this power of 4 means there are 4 of these a cubes, and there's also 4 of these b to the 6. So the 4 just get multiplied by each of the exponents inside the bracket. So 3 times 4 is 12. The 6 times 4 would be 24. So a to the 12th, b to the 24th. For c, 3x to the fifth squared. Now, it's a really common mistake to forget about the coefficient in front and not square it. But everything's in here has got to be squared. So it's really 3 squared and then x to the fifth squared. Well, we square 3 by just going 3 times 3, which of course is 9. And then 5 times 2 would be 10 for the exponent in the x. So that would be 9x to the 10th. Again, you go directly here to here. If you go 3 squared is 9, 5 times 2 is 10 for the exponent in the x. Now for d, we're cubing this, and it's a good idea if you recognize that you can simplify what's in here first and then cube it. So that's a good idea. Make it simpler and then do the power of 3. So 18 over negative 12, I could divide 6 into both of those. 6 goes into 18 3 times, and 6 goes into the 12 twice, and there's a single negative. I'm just going to put it in the middle here. And then x to the 8th divided by x to the 3rd, we subtract the exponents, so x to the 5th, and y squared divided by y to the 1st would be y. Okay, and then we could cube this. And so when we cube it, of course, negative 3 cubed is negative 27. That's why there's a negative here. X to the 5th cubed, 5 times 3 is 15, and y cubed would be y cubed. Don't forget about the 2 in the denominator. 2 cubed would be 8. Now, if you didn't do the simplifying, then you could actually cube all this and cube all this. Okay, and it would actually, it's a big number. 18 cubed is 5,832. 8 times 3 is 24. 2 times 3 is 6. If we cube negative 12 times negative 12 times negative 12 is negative 1,728. And 3 times 3 is 9. 1 times 3 is 3. Okay, and if you simplify that, you will get this. If you simplify 5832 over negative 1728, you will get negative 27 over 8. Subtract the exponents. 24 minus 9 is 15. 6 minus 3 is 3. So it does work. But simplifying first is a little more efficient way to do it. Last one here, e. We've got some multiplying, power of a power. And if you remember order of operations, a lot of people call it bed mass, do the powers first. So cube this, square this before you multiply. So don't forget bed mass. So doing the cubing first here, 2 cubed is 8. Q cubed, so 3 times 3 is 9. R squared cubed, 2 times 3 would be 6, and then times. Negative 5 squared means negative 5 times negative 5, which is 25. Q squared is q squared, and r cubed squared, 3 times 2 gives you 6. And then, of course, we have this 10 q the 14th, r the 8th in the denominator. Now, what I'd suggest is multiply those two monomials on the top together and then do this division. So 8 times 25 is 200. 9 and 2 add to 11 when we multiply the two powers of q, and 6 and 6 add to 12. So now to divide this, we would divide 200 by 10. Of course, that goes in 20 times. And notice that the larger power of q is in the denominator. Actually, I'll put the answer up here. So because the larger power of q is in the denominator, go 14 minus 11, and the q cubed stays in the bottom. And the larger power of r is in the top, so 12 minus 8 would be 4 in the numerator. So 20 r the 4th over q cubed would be the final answer.